Hey there, friends and neighbors. I'm now going to show you how to do the repeated measures t-test, which is what we're going to do for the Real Data Homework 9, the second half of it. This involves a different data set, your test scores data set, which is available in the assignment. So the first thing you want to do is download the data set. Whether it be the Lutyens or the test scores, you download the data set. It's in the assignment. Okay, so now the first question is, are they independent or dependent? You figure that out on your own. We measured these people repeatedly. Everybody has test 1 and test 2 and test 5. They're all the same people, so you can decide if those are two independent groups or if it's the same people measured over time. Identify the appropriate analysis, and now we're going to just do it. So let's preview. Here's your question. All right, so in the test scores data set, we're going to do the appropriate test to see if in the population test 1 is easier than test 2. Well, if that's true, then the mean for test 2 will be lower than the mean for test 1. Okay, let's go ahead and show you how to do this with R. You open up R Commander, Easy R. And if you don't know how to, if you haven't already loaded, set Easy R to automatically load, then you need to type the instruction library R Commander. And then once it comes up, you go to Tools, Load R Commander Plugins, Easy R. You click OK. But mine is already there. So next thing we're going to do is import the data set, File, Import Data. Again, you have to download the data set. Maybe you call it Test Score. I don't know. Tests. That's good. So OK. You go find out wherever you saved it. You double click on it and you open it. Now mine's already open, so I'm going to close it. OK. So how do I do the paired t-test to see if test 1 is easier than test 2? I go statistical analysis, continuous variables because it's quantitative, and I go to paired t-test. Okay. Once I'm there, my first variable is test 1, and my second is test 2, because we're testing to see if test 1 and test 2 are different. Now particularly, I'm going to say test 1 minus test 2, and if the alternative is correct, then that's a big number minus a little number. If test 1 is easier, then its score will be bigger. So big minus little, a big number minus a little number is going to be greater than 0. Then I click, and this is the hard part, OK. I'm going to scroll up and get to my results here. Here's the T. The T is 1.4037. Copy. Paste. Get the degrees of freedom. They are 58 for this example. And just so we're clear, your answers are not going to be the same as these answers. The numbers are different every quarter. I'm showing you the steps on how to run a paired t-test. I'm not showing you the answers. Okay, then I go get my p-value, 0.08 something. Copy. And paste. So, that p-value is bigger than alpha. Our typical alpha, if nobody tells you what it is 0.05. We typically just assume it's 0.05. That's bigger than alpha, so I failed to reject HO. And that's that. Okay. Why is my p-value wrong? I don't know. I think I said it wrong. I'll have to fix it later. I definitely did this right. Okay. I'll figure that out later. Now, the next question asks you to compute, well, it's another paired t-test. This time we're comparing test 2 to test 5. Let's go ahead and do that. Statistical analysis, continuous variables, paired t-test, test 2 against test 5. Now the alternative hypothesis is that test 2 is easier than test 5, which means test 2 will be a bigger number than test 5. So test 2 is bigger than test 5. That would be, again, when I do 2 minus 5, that would be a right tail alternative. So I click OK. Scroll up. And here's my t-test statistic value. Copy it. Paste. Here is my degrees of freedom is 58. Copy. Paste. And finally, my p-value. I think I know what I did wrong. I think when I put in the answers for it, I probably made it 2 tail. Yeah, that's probably it. And paste. And then, so that is definitely smaller than alpha, so I will reject HO. And that's that. Okay, I need to fix those p-values. It's okay, I need to update it with your quarters data anyway. So that's how you run those tests. We need to interpret what it means. I need to decide whether it's causal inference or not. This is not a true experiment. I did not randomize people to conditions. So this does not necessarily prove that test 1 is harder than or easier than or different from. It doesn't prove that difficulty is the only explanation because we didn't use random assignment to conditions. The last question is to make a histogram of grades. That's it. So make a histogram of grades, save it, and upload it. Here's how we do that. You go to R. The data set is already open. Graphs and tables, histogram, grades. And then you click OK. And then you can right-click, save it in any format that you enjoy most of all, upload it. I will be able to see it, I'll read it, and I'll score it. And that'll be that. All right, I look forward to seeing these responses and answering your questions. We'll talk more later.